Welcome to Mastering Solutions. In this general problem, they want us to figure out different aspects of the E. coli and to convert those into the SI base units and then use the correct significant figures. Don't get intimidated by this problem because it looks really scary, but as we break it down going through the parts, it's really not too bad. So starting off with part A, they say, what is the length of it? And obviously it's given right here as 2 microns long. So we have 2 microns, but we have to put it into base units, which is just the meters. So micro stands for 10 to the negative 6. So simply we could just put 2 times 10 to the negative 6 meters, and that is now in SI base units. Going to B, same thing. They say it is 1 millimeter in diameter. So we have 1 millimeter in diameter. Putting that into base units, the milli stands for 10 to the negative 3. So 1 times 10 to the negative 3 meters. And if you want, you could also move the decimal places on both of these. 1, 2, 3. So we'd have 2 zeros. So 0.001 meters is the same thing. This one, you can move the decimal place over 6, which would give you 5 zeros. 2, 3, 4, 5, 2. So 1, 2, 3, 4, 5, and 6. So you could also do it this way. I feel like it's way easier just to convert what this stands for. So 2 times 10 to the negative 6 and 1 times 10 to the negative 3 meters. Moving on to part C, they say, what is the mass? And they say the mass is 1 times 10 to the negative 12 grams. So 1 times 10 to the negative 12 grams. We want grams to cancel and we want to be in kilograms. And we know in 1 kilogram, there are 1,000 grams. So you can plug this into your calculator, but if you think about it, we're dividing by 1,000, so you would just move the decimal place over 3. It gets confusing for some people because we have the exponent here, but we're going to be making this smaller because we're dividing it up into further sections. So we'll actually just increase this by 3. So the answer here is 1 times 10 to the negative 15 kilograms, which makes sense, right? Because we're going to kilograms, which is bigger. So we're going to have more grams if we divide this up into more sections. All right, and let's move on to part D. And so for D, they say, what is the length of the DNA in millimeters? They tell us the DNA is 700 times longer than its body length. So the body length was part A. So we'll have 700 multiplied by 2 times 10 to the negative 6 meters. So if we plug that into our calculator, we have 700 times the length, which we said was 2 times 10 to the negative 6 is 0.0014. So we have 0.0014, and that will be meters. We can put this into scientific notation, and here's 1, 2, 3. So we have 1.4 times 10 to the negative 3 meters. And if you remember, 10 to the negative 3 stands for milli. So you could also put millimeters, but we obviously want SI base units, so we'll leave it here. All right, and so now last one for part E, they want to figure out how far it can move in one day if it were to just move in a straight line at this speed right here of 20 microns per second. So let's put this into SI base units. So we have 20 microns per second. And we can change the micron to 10 to the negative 6. So we have 20 times 10 to the negative 6 meters per second. And now we need to move the time, which they tell us is a day, into SI units of seconds. So in day on the bottom, that will cancel out 1 day. There are 24 hours, so now days are gone. And then in 1 hour, it'll be opposite, so the hours will cancel. We have 3,600 seconds. So now you can do 1 times 24 times 3,600, 1 times 24 times 3,600. Obviously for the calculator, you don't actually have to put in the 1. It's the same. I just did it for completeness sake. So we have 86,400 seconds. 86400 seconds. And we could put this in scientific notation so it's a little bit easier to work with. So we have 1, 2, 3, 4. So that is 8.6 times 10 to the 4 seconds. And so now we need to figure out our formula. Velocity, of course, is the change in distance over the change in time. But we want to figure out the delta x. So if we isolate that, we'll just move delta t over to the other side of the equation. So delta x is equal to the velocity times the change in time. And now we can just plug these in over here. So delta x is equal to the velocity, which we said is 20 times 10 to the negative 6 meters per second. Let's give this a little bit more space. And then that will be multiplied by 8.6 times 10 to the 4 seconds. And now when we plug that in, we get 20 times 10 to the negative 6. And then we'll multiply that by 8.6 times 10 to the 4. And so we have a final distance of how far it went in a day is 1.72. So we can round that. So delta x is equal to 1.7 meters for how far the E. coli can go in one day if it were to go in a straight line.